Let's consider this system again. Um, Forget this title for the moment. Let's consider this system AX equals B. We did some row operations, and here's what you get. In fact, it's in reduced row echelon form. And this B with the hats means you did the same row operations on the right side of this equation. So we probably did it by doing the augmented matrix. But let's look, we're interested in the column space now. When we did matrix rank, we covered row space pretty thoroughly. Now let's look at columns. Let's look at the column space, which means this linear combination of the columns, right? All the things this could equal, whatever you pick the variables to be, that's the column space. Remember, it's the span of that. It's the span of these column vectors. And then let's just pick out the pivot columns, which were 1, 3, and 5. Here they are. You go ahead and do this linear combination, and what they are is this, which means you could make this guy 0. Well, the only way to make the linear combination to be 0, which is a test for linear independence, is if all three of these variables are 0. So the pivot columns are linearly independent. We just did the test for linear independence. What about the non-pivot column? Well, let's take the 3 pivot columns and just try the non-pivot columns one at a time. Here's trying X7. I could pick certain numbers for these coefficients to yield a 0, and they didn't have to be zeros. So these 4 vectors are not linearly independent, but these 3 vectors are. So this guy is not linearly independent of the rest. We could do this test on all the free variables, all the non-pivot columns, and you end up with the same thing. So that the non-pivot columns are not independent of the pivot columns, but the pivot columns are independent of each other. We call those non-pivot variables the ones corresponding to the non-pivot columns. We call them the free variables, and they will always be n, the number of columns of A, minus the number of pivot columns. Meaning the number of free variables is the rank, or excuse me, it's n minus the rank of A. N is the number of columns of A, it's also the number of variables. In this case, it was 4. We had 7 total columns, only 3 pivot columns. So what about dimension and basis? The dimension of the column space of U is rank U. That's also the rank of the matrix A. So that's the dimension. So the dimension of the column space is the rank of the matrix itself, same as the row space. That's a good thing, isn't it? It kind of means we could have defined rank by either rows or columns. A basis for that space, the column space of U now, is the pivot columns of U. But we want the dimension and a basis for A. Well, A has a bunch of columns, n columns. Each of these A's with a subscript is a column of A. We then do row operations to come up with U. So here's all the columns of U. Or we could call them these little columns, U sub 1, 2, etc. And these, remember these E's are invertible, so we could recover the A from U, which means this. So A equals both this and that, and U equals both this and that. We have one-to-one correspondence between the little a's here, the columns of A, the columns of U, and the columns of U and the columns of A. Either way, we could go. Got a one-to-one correspondence. So We do the linear independence of the columns of U using this test. And we already knew that relationship. The pivot columns were independent, non-pivot columns were not. But this relationship, if I take this same relationship, multiply by this E inverse, carry that out in there, I get the A's. The same relationship with the A's as with the U's, meaning the same columns of each will be linearly independent or not linearly independent. So the dimension of, they're all the same. The dimension of the column space is the same as the rank of A, which is the same as the dimension of the row space. But furthermore, the basis for A are the columns of A that correspond to the pivot columns of U. So now we have a way to find a basis. I think I'll do an example next in another video because this is going on too long.